All right, so let's go ahead and take a look at this problem set. So let's scroll down here. Okay, so find this derivative. So f prime of t is equal to, it is going to be the product rule. So it's sine of t times 5 plus 5t sine of t is cosine of t. And then minus 3 sine of t. So when I look, I get 5 sine of t and 3 sine of t make 2 sine of t. And then this is plus 5t cosine of t. So 5t cosine of t is this one here. Okay. Here's 3. So the second derivative. So just make sure you guys read. H prime of x is equal to secant of x times 4x cubed plus x to the 4th secant x tangent x. So h prime of x is equal to 4x cubed secant of x. Ooh, this is going to be so sad. X to the 4th secant x tangent x. Now I want the second derivative. When I do the second derivative, I'm going to have to do product rule here. So I'm going to move all the way over here. It's not t, x. Okay, so I have secant of x. And then I have the derivative of 4x cubed, which is 12x squared. And then plus 4x cubed, derivative of secant is secant x tangent of x. Okay, so that gives me the derivative of the first part. Then when I do the derivative of the second part, what I'm going to do is I'm going to do, I'm going to group them differently. So I'm going to group my x to the 4th secant of x, and then I'm going to group tangent of x. So then that way when I take the derivative of this x to the 4th secant of x, I'm going to use product rule there. So I copied down the second. So that's tangent of x. Then I take the derivative of x to the 4th secant of x, which is a product rule. So that's secant of x, 4x cubed, plus x to the 4th secant x tangent of x. And then I have copied down the first, and the derivative of tangent is secant squared. And now I need to combine like terms. So h prime of x is 12x squared secant of x plus 4x cubed secant x tangent of x. Then plus, I am distributing my tangent. So this gives me 4x cubed secant x tangent of x plus, let's clean that up a little bit, x to the 4th secant x tangent squared x plus x to the 4th secant cubed of x. These together give me 8 of them. So this is h prime of x is equal to 12x squared secant of x plus 8x cubed secant x tangent of x plus x to the 4th secant x tangent squared of x plus x to the 4th secant cubed of x. And what you notice is that all of them have a common x squared at least and a common secant of x. So I can factor that out. H prime of x. So I have x squared secant of x, 12 plus 8x tangent x. And then this guy is plus x squared tangent squared of x. And then this guy is x squared secant squared of x. And then you just have to pick the one that works. Let's see, 12. x squared secant, 8x tangent. So it is A. Okay? All right, so let's see. Question 4, question 5. Okay, so y prime is equal to tangent 5x to the 4th plus x to the 5th secant squared of x. So it is D. There's question 6. Okay, so then we go to the next problem set. Find the derivative here. So y prime is equal to cotangent of x, 2x plus x squared negative cosecant squared of x. So y prime is 2x cotangent of x minus x squared cosecant squared of x. 3, y prime is tangent of x, cosine of x, because that's the derivative of sine, plus sine times the derivative of tangent, which is secant squared of x. So, y prime is tangent x, cosine x, plus sine x, secant squared of x. 4, 5. Quotient rule. Low d high minus high d low over low squared. So y prime x secant x tangent of x minus secant of x all over x squared. That's 6. Here's 7. So you could do this a couple ways. You could just do it product rule the way it is right now, or you could distribute if you would like, and then do product rule here. I don't think it necessarily matters, so we'll just do it this way. So y prime 1 plus cosecant of x. Derivative of cosine is negative sine of x. And then plus cosine of x. Derivative of 1 is 0. Derivative of cosecant is negative cosecant x cotangent x. So then I have y prime is equal to negative sine of x plus cosecant of x, sine of x plus cosine of x, minus, just kidding, minus cosine of x, cosecant of x, cotangent of x. Okay. I do want to see if anything cancels out. So I have a negative sine of x plus 1 over sine times sine. So that'll give me 1 minus cosine of x. Cosecant is 1 over sine, and cotangent is cosine over sine. So essentially what I have is y prime is negative sine of x. My sines cancel out here, so I'm left with 1. And then I have minus, I have 2 cosines here and 2 sines. So I really have cosine squared x over sine squared x, which is the same thing as cotangent squared of x. So technically this is y prime is equal to negative sine of x plus 1 minus cotangent squared of x. All right, cool. And that is it for this problem set.